everyone. Thank you to be here today. I want to remember that the current session will be TLP White, sorry. This session name is Follow the Dynamite, Commemorating TeamTNT Cloud Attacks. And to speak about it, let me to introduce Nicole Fishbein and Joakim Kennedy. Thank you, guys.
Thank you, everyone. We just want to kind of give you guys a walkthrough of the the activity of a threat actor called TeamTNT. There we go. My name is Joakim Kennedy, and I'm a security researcher for Intezer. I kind of consider myself as a assembly reader. I spend most of my day sort of looking at suspicious binaries and things like that. When I don't do that, I also hunt for gophers, usually malicious Go binaries. I have a open source project for binary analysis of Go binaries that is hosted on GitHub. Go.
Hi, my name is Nicole Fishbein. I'm a security researcher at Intezer. And previous to that, I was in the embedded R&D department in the IDF. So today we're going to present you TeamTNT. And I will present the chronological order of their saga, which is kind of a Shakespearean tragedy story, because it started pretty well for them with targeting Redis servers. Then they moved to the Cloud9, targeting different cloud infrastructures. And they got really famous. They have a very active Twitter account. And then they had to deal with the cost of fame when copycats started to show up, and right until the end. So who are TeamTNT? It's a group, it's a threat actor that targets cloud infrastructures to mine cryptocurrency. Basically cryptojacking. Cryptojacking means mine cryptocurrency on someone else's computer. And cryptojacking is the most popular threat to the cloud. And TeamTNT is the most active threat actor that we can attribute attacks to. So we will start right from the beginning. OK, so the beginning. So this kind of era kind of starts in around like winter 2020. They started to target Redis servers. And what is kind of unique with this kind of start was the use of PN scan, which is something we usually see crypto mining threat actors do. They download it on an infected machine, and they scan for others, and then just sort of spread as a worm around it. But the interesting thing with this actor was not the sort of use of a massive shell script. Instead, everything is broken out in a lot of shell script files. In addition to that, they also utilize some binary tools. One of them that's very that they liked a lot is we track as like Tsunami. It kind of was downloaded as this whois.irc. It's a IRC bot that is designed for denial service, and hence sort of like where the Tsunami comes from, because it's one of the keywords that you can send to the bot, which is basically to flood everything. The other use is a Linux backdoor called RatHole, relatively simple, and provides just shell access with encryption. And in addition to that, they also had a binary that sort of operated as a watchdog that made sure that everything was running. And to do some lateral movement, they utilized a post-exploitation tool called PunkP, which I think is all the way back to like Packet Storm and stuff like that, but nowadays you can also find it on GitHub. The interesting bit here is that even from like the beginning, they started to sort of exfiltrate credentials and trying to sort of spread within the network. There were some interesting ways of doing this, where they would go through bash history and steal keys or whatever. Now, the initial name of where like TeamTNT come from is the first use of sort of the registration of their domain name, which they registered, as you can see here, in February. Now, on this sort of server where they hosted, so they hosted all of their tooling on this server
We could sort of manage to get some stuff that was sort of dated relatively early. Here's, for example, is something that was uploaded or added to the server 4 days after the registration of the domain name. So it's like one of the earliest tools that was out there. This is kind of the nightmare of shell script that you have, just to show how things are sort of connected. It starts with the shell script in the in the middle called load/setup.sh. That's sort of a folder name, because it has a couple of other loader. It will download all of these other tools and stuff like that, which sets up the sort of the spreader functionality, the mining part, and some other stuff like just to grab credentials. The one thing that's very interesting with this group is from the beginning, they slapped on like a copyright header on their shell script. So here we have, it's describing what it is. So this is, for example, we see the top one there is the shell script that focused on compromising Redis, and it's their private module with a copyright of HildeGard, which is the handle name for the TeamTNT operator. We also have a poor man's SSH keylogger and things like that. Also, throughout sort of the shell scripts, all of the comments were in German. So it's kind of like the first sort of hint that maybe this is actually a German threat actor. Now, they're also utilizing some really interesting, like homemade kind of tricks to kind of do stuff. Here, for example, is a shell script that is installed, who's designed to hide files. And as you can see, what it's doing, it creates sort of like a bind mount or like a NoFS mount on like a BSD, where it's sort of linking a folder, and it does it over the where in the procf file system, where sort of like the process information would be. So it turns to hide itself by doing that. Now, unfortunately, on like most Linux distribution nowadays, this mount tab is just a link that it's sort of manipulating with that points to the procfs. So it's not a file that exists on disk. And also, if you run some of the commands to list sort of mounted folders and things like that, the tool is not using those files at all. They're kind of just provided there for shell access. So it was a nice attempt, but I don't think it worked that well on the actual infected machines. The credential stealing method, so this is the poor man's SSH logger, just uses strace and looking for specific syscalls and just logging it, and then having sort of a cron job that runs and sort of uploading the logs in a hope that like someone logged in and authenticated to another machine and sort of grabbing those credentials. So the Tsunami botnet, so this is, from the beginning we saw this one, and this is the one that they've used all the way till the end. It was used sort of as a secondary access once they've sort of got control over a machine. We can see how it's a newer version. Oh, sorry, it's a old version of Chitin or Sigistar Tux. These are two like incarnation of sort of like this malware that you can find source code on GitHub. There's plenty of like repositories where this one that they're using doesn't have the new functionality, so it's taken from one of the original sort of source code. As I said, it has the DDoS functionality, but it also provides a shell access. The way it ran on there when they infected it, it will change its name to sort of masquerading as a kernel thread. The RatHole, as I said, is just an open source backdoor. It's used Blowfish for the encryption. And the interesting bit is like the key that they had was TeamTNT. So they started kind of putting their mark on their stuff. Now, those were kind of the artifacts that we could get from where they started to utilize sort of like the TeamTNT. But luckily, this RatHole binary was actually uploaded to VirusTotal a couple of months earlier. So here you have sort of like the posting of it when it was first uploaded. And sort of utilizing where this one was shared from, we could actually pull back and find other activity that they have done before. And the interesting bit here is in the screenshot down, they had a user with a username called Hilde, and then the password, if you crack it, is guard. So this is a name that you will see. It was both in sort of like the copyright, and you'll see sort of even like in all of the activities that they have.
All right. So spring 2020, that's when we saw the major shift to targeting Docker and not only Redis. But also in spring 2020, the first documentation of TeamTNT's activity was published by Trend Micro. So that's when other vendors started to track them.
Yeah.
Can you hear me?
Hardly.
All right.
Do I try here on the mic here? Yeah.
Thank you. So spring 2020, that's when the first documentation of TeamTNT was published by Trend Micro. And that's where the major shift to targeting Docker environments made by TeamTNT. But they still continue to use open source tools and scripts to deliver the threat and carry on the malicious activity. To target an exposed Docker instance, they first would scan the network using masscan and zgrab, two open source tools. Once they would find an exposed Docker instance, they would create a legitimate image of Alpine and set it to execute to download a certain script that will download all the other scripts that will execute the attack. And similar to what we saw before, we have one script that will call another one, and then each script has its own dedicated task. Could be installing persistence, evading detection, and executing the next components of the attack. And an interesting thing that we were able to find is when we looked into the different scripts, we found a URL. And then we analyzed what other scripts communicate or using this URL. So we found another script on VirusTotal. And the interesting thing is that it didn't target Docker, it targeted Redis, but it was uploaded in spring 2020. So it means that TeamTNT didn't entirely shift their focus from Redis to Docker. Rather, they expanded their victim range. And another interesting thing is that this script still has two detections on VirusTotal. And spring 2020 is when the COVID-19 pandemic spread and affected each and every one of us. Many threat actors still using the pandemic to deliver threats and phishing attacks. But TeamTNT started to use COVID-19 keywords and buzzwords in their scripts and URLs for no obvious reason. Maybe they decided just to go with the flow with other threat actors.
Thank you. So the summer, I'd say they moved away sort of from the Redis part, and Docker became sort of their bread and butter. Now, there was some minor changes to it. Here is one of the setup scripts that they utilized, where it first tries to fetch what appears to be a JPEG, but it is just a shell script. And the new part here was like, if that failed, they just base64 encoded the shell script as an alternative. So because of the OR bar in the double OR, if the first command fails, it will do the other one. So even if their server goes down, it would still sort of spread through it. The other kind of shift we saw here was that they actually started to go more hardcore with regards to rootkits. So here is sort of a script that downloads Diamorphin, which is a open source kernel level rootkit, and it would download and compile it on the machine and load the kernel module to hide the mining that was going on. The credential harvesting expanded. Here you have a sort of a list of all the different kind of files where it was going through. So it would go through and look for all of the known hosts for SSH, all the user accounts and SSH keys and things like that. And then it just would loop through and just try what would work and sort of just to spread within sort of like its network.
Fall 2020 was the time of different changes and updates in TeamTNT. The first thing that our research team was able to find is that they use a tool called WeaveScope, which is an open source tool to control and monitor your containers. Once installed, it's relatively easy to install. And once installed, it creates a dashboard that you can access through the browser. So you have all the files, all the resources, all the processes that run on the container, and a really nice shell to execute commands. And it's open in the browser, and it can be set to have access from outside of your network, so anyone can access it. So once TeamTNT found an exposed Docker instance, they would install WeaveScope, and basically they had a full backdoor without developing a backdoor, and by using a legitimate tool, so they evaded detection. Then, once again, they expanded the credential stealing capabilities using, once again, open source tools. MimiPenguin is similar to Mimicuts, but only for Linux. So it dumps all the processes, looks for passwords. And MimiPy does the same, but it also supports extraction of passwords from HTTP and browser communication. As reported by ESET, TeamTNT started to use Izuri. So Izuri is a cryptor or a packer written in Golang, and it's open sourced. And it takes the payload, encrypts it with AES, and that's how they were able to evade detection of standard tools. Their social media account on Twitter is very active during this time period. And they tweet a lot about their activity, about different things. And that's how we were able to find more information and better understand this threat actor. We took all the tweets and started to analyze them. So we wanted to understand what are the active hours of the threat group, maybe to understand where they're located. And as you can see, they're more active during the late afternoon and evening. However, they're active the whole day. And that's how once again, we think that they're in Germany because of all the tweets that are in German or talk about German news and related topics. Another very interesting thing is that they openly talk about their activity. They're not hiding it. And they're not thinking of themselves as the bad guys or threat actors. And they're very responsive with the researchers and with the community, which is really rare. So here, for example, they replied to a research that we posted about one of their campaigns, and they refer to this mount trick that we covered a few slides before.
So the winter. So during the one of sort of the reports that came out about the group from Lacework, they got onto one of the IRC servers that they use to control the Anomali bots, and reported that about 200 infected bots at sort of like activity kind of around that. Now, of those 200, it was 90 of them from unique IP addresses. So we've already seen that they are very heavy on like the lateral movement, so it kind of suggests that they are actually effective in managing to move within the network. Also, the threat actor has also reported of a couple of vendors that they keep sort of trawling into their network, and he kind of found annoyed that he just kept getting in and stuck in their networks. In general, from sort of like the IP addresses, most of it was just cloud-based cloud providers. Majority of them were based in Asia, but not just like Asian companies and just their endpoints. So you have the vendors up there in general who was there. Additionally to this, now they all also added a secondary kind of method for their rootkit functionality. So they started to download this libprocess hider. It's a open source tool, kind of follow with the same theme as they've always been doing. Utilizing a different method to achieve sort of a user-land-based rootkit. Which makes it a little bit more portable. It hooks, like, it loads itself into processes using the linker, so you can sort of manipulate the world around, or like the infected machine, and sort of stay hidden. The other shift that happened here was that they moved away from Docker and started to directly target Kubernetes. We also saw more use, like pretty much all of their binaries at this point were using the same packer to sort of stay hidden. One thing that we were surprised to kind of find was when we're sort of looking at some of the files that sort of been, or like connections that VirusTotal had recorded for like their infrastructure, we noticed these URLs. And some of these files are detected as Windows files, or PE files. So could it be that they were sort of moving on to targeting Windows servers? And one of those files is just a compile autoit script that is called they call it a sniffer, and it's pretty much what it is. It will actually just install WinPCAP and then perform packet capturing and look for specific credentials and stuff like that on the wire. And the other one is a miner that is specifically compiled for CUDA, so like the NVIDIA graphics card. Additionally to that, this miner also will drop a Windows driver. This driver allows for sort of like ring 0 access. And it's actually part of the miner itself to set up a couple of CPU registers to improve performance. So it's part of the legitimate miner, but probably not recommended to have it on your machine, because a user lane can reach into to ring 0 and do any manipulation for the sort of like this via this driver. There's no sort of protection in that.
So next, they continue to extend their credential stealing capabilities, as reported by Trend Micro. So they moved from targeting only AWS or SSH, looking for crypto wallets IDs, GitHub API keys, and so on. And on top of that, they use the AWS CLI tool, which is a legitimate tool that provides lots of information about the instances, the framework, the volumes, the network connection. That's only a small part of a huge script full with commands of AWS CLI that TeamTNT executed on a compromised environment. And a report was released saying that 50,000 IPs from China were compromised by TeamTNT. And that's where they replied and said, that's not us, and the numbers are not quite right, and you should check your facts. And then another researcher connected some scripts to one of TeamTNT's campaigns. Once again, they replied saying, that's not us, and someone else is using our old scripts or our techniques. So it seems like some sort of a copycat, someone else is using TeamTNT's scripts and techniques. Because another report that attributed some more attacks and campaigns to TeamTNT was published, and once again, they responded. So we learned that, first of all, someone is trying to use TeamTNT's artifacts to spread more malware. And TeamTNT refused to take the false connection.
So this kind of idea with like the copycat obviously didn't go well with them. So they kind of decided to come up with a way of like, how can we make sure that security researchers and things like and people like that, us, actually would know that this is TeamTNT. So they put this information out saying that they would start sort of tagging the stuff, which include like a link where you can get the most recent version of the shell scripts that we're using. And they also did that. So they added this to the headers for all of their shell scripts. Tells you what it is, and the name of it, and a version number, and also sort of like the date when it was created. This was kind of part of a new kind of campaign that they called during the summer called Chimaera. And you have they put up this new website, and you can see kind of like where they were targeting, which different instances. So we have both Docker, Kubernetes, and WeaveScope. And they were trying to kind of create like a live dashboard to say like how many machines have we managed to compromise, and how many what's our hash rate. But clearly like this overwhelming of like copycats and kind of overwhelmed them. And then eventually towards like the fall, the activity dropped. And then towards like in November, they put this announcement out where they sort of said that they were done. And they put this URL here. It just is a link to I think it was a zip file or a web directory where they have all their tooling, including source code. So unfortunately, what that leads to today is that you see a lot of like TeamTNT stuff, but it's all coming from like this stash. So there's a lot of like threat actors that sort of utilizing this. Their Twitter handle has gone quiet in terms of the crypto mining part. They still tweet, especially around like German policies and politics and stuff like that. But they kind of have tried to move away from the crypto jacking part. So just to conclude sort of the conversation here. So in general, we would say like the crypto jacking is like one of the major sort of threats to Linux environments. There's actually a lot of threat actors out there doing it. The barrier to entry is relatively low for them. They utilize all the same exploits, and sort of to protect against this is relatively easy. It's just make sure you use solid credentials, so no weak passwords. Patch your stuff. And don't expose stuff that shouldn't be exposed. What TeamTNT utilized a lot was the misconfiguration of Docker servers that had the API listening on the internet, which allowed anyone to send whatever command you wanted to the backend and spin up whatever images you wanted. Now, during this time, TeamTNT was sort of like one of those predominant actor. They sort of resulted in the most compromised machines. And their focus was most of the time around Docker and Kubernetes. The interesting bit is that compared to all of the other sort of crypto jacking actors that we've seen out there, they had a very strong public presence where they would tell threat researchers if they were wrong, and also, as we saw in some of these tweets, they would share how successful they were, which is quite of an interesting sort of scenario. So that leaves us with it.
So thank you, Joakim. Thank you, Nicole. Some question for Okay, there we have one from EISP. So.
Yeah.
Thank you for the talk. Great talk. It's very interesting. I'm curious about something because we are following another group which is basically using Tor web gateways and accessing HPC infrastructures. Exactly the same techniques. The tools are even, I think, the same. Scripts are the same. I don't see the German part. And for what we know, they seem Chinese because the first connection they do to their backend infrastructures is from China. And when we look at the translations, we were wondering if it's not Chinese using automatic translations or something like that. Did you try with the dataset that you have to automatically translate all the text to see which one makes sense, to see if the original translation is not coming from another language?
Good question. No, we actually didn't do that. Most of the stuff we were looking at, we looked at the historical part, and we just was following along as they were changing the scripts. When sort of like that copycat stuff came on board, because we'd looked at so many of the scripts, we could see that this was a hodgepodge of like, it's not there. It doesn't follow along with what they were doing. Yes, it's like it was pulling the stuff from their old server, which I think was a compromised web server. But there was so much other stuff going on that just, it was such a drastic change. It's like we saw like they used this technique and then you would see this completely different thing and then back to that normal again. And it made no sense, those jumps. And also when we looked back further, it was the same thing as they were saying, that those are old scripts. And they matched pretty well with the older stuff too there too. So it kind of made sense. Some of the paths too was very similar to like another crypto miner. I think some vendors are tracking it as System D miner or something like that. So they were the one that sort of picked up. But yeah.
Thank you for the question. We have another one.
Yeah, comment to the previous question. When you showed the tweets as a native German speaker, you know, it read all great grammatically until at some point, and then it was like, what? The grammar is wrong here now. Are they smoking pot or something? I don't know what, yeah. But so maybe that there is an indication that there is something there. Anyway, my question is, or my comment is that when you run Docker by default on Ubuntu, at least, Debian as well, you totally evade UFW or IP tables. So maybe that is something, a really quick trick for lots of Linux systems to actually not have that by default, because many system admins might not even be aware that it's actually Docker opens that and they configured the IP tables properly, but then Docker goes just next to it. Yeah. Did you encounter that in your research also?
I think it's not part of the research per se. Do you want to talk? Yeah. I know you did some research on this part.
The initial configuration of Docker, when it's installed, it actually doesn't expose these ports. And I just saw different guides that guide people to expose these ports because then it will be easier to access the containers. So that's how I think most of the misconfiguration happen.
Yeah.
Thank you. There is no more questions, so thank you again to Joaquin and Nicole.
Yeah.
Big applause for them. Thank you, guys.
Thank you.